go over from either problem set 39 or 40? Yes. From which one? Problem set 40, number 16. Problem set 40, number 16. So we're on page 164. Yeah, please make. What?
I shut it down.
Why?
So I can get notifications.
Yeah. Hopefully, when you're checking your work, having trouble with problems like numbers 16, 17, 18, and 19, those ones in particular, those are types of problems. Please pay attention. At least have the problem set out in front of you.
Can I take my sister real quick?
No.
She's outside.
Just
She's
go.
She's at
Go.
the code.
Okay, then go.
Oh.
Just go to her. Please put that away. All along, we're on page 164. We're looking at problem 16. You should make sure that you know how to do 16, 17, 18, 19. These are types of problems that trip guys up a lot. So let's look at 16. It asks us to factor the greatest common factor. They give us 4a squared x y to the fourth p minus 6a squared x to the fourth. Now, when we're factoring the greatest common factor, what does that mean? What are we looking for here? Yes?
They're looking for something that they both have in common. The greatest thing.
Right, the biggest thing that they both have in common as factors. The biggest thing we can divide out of all the terms. So what do we have here? Yep.
So like 2.
2, because that's the greatest common factor of 4 and 6. Yes?
A 2. It's the same time.
A squared, yes?
And then
X.
So that's what I got, and then I just have it back.
Okay, so when we're factoring out the greatest common factor, we're not just finding the greatest common factor, we're also then going to undo the distributive property to this, so to speak. So we're going to rewrite the whole thing as something that is equal to. So if we divide 2a squared x out of each of these terms, what are we going to get? What are we going to get if we divide 2a squared x out of the first term?
2.
2?
A. No. 2 y 4.
2 y to the fourth p, yes.
P minus -3.
Minus 3.
X c third.
Yes. Minus 3x cubed.
Oh.
That's all. So once you find the greatest common factor, you're then going to divide it out of all of your terms. Thank you. You're going to divide it out of all of your terms to make sure, like you're undoing the distributive. And then if you want to check this, you can then apply the distributive property of this, and you should end up with what you started. Yes, but 16, 17, 18, 19. 18 and 19, those ones go well for everybody?
No.
No? Okay, let's do one of those then.
Or 40?
Yeah, problem set 40.
Which one?
Problems 16, 17, 18, 19. We just did 16.
It's 1 minus 2.
You do 18?
18, yep, let's do
Isn't that
18.
where you like cancel them?
Right, so 18, we're trying to simplify this fraction that they give us. We have 6x minus 36x squared over 6x. Now, what's the problem with simplifying this fraction in the form that it is currently in?
I don't know.
What's the problem with trying to do that?
This is homework. Yeah. Look at it.
What's the problem with trying to simplify this? What does this line in the fraction mean? What's connecting these two terms on top? Am I allowed to use division to undo subtraction? No. I can only use division to undo multiplication. All right, so we're going to need to rewrite something, rephrase something, reformat something to make it so that I can use this division to cancel something out. The way that we're going to do this, usually, if you have something like this, where notice we have two terms connected with addition or subtraction on top, is we're going to try to factor out a greatest common factor. So if we do that to the top, what are we going to have? We're not going to change the bottom of the fraction. What's the greatest common factor of those two terms on the top of the fraction?
1. Oh, 6. X.
The greatest common factor of 6 and 36 is 6. We can divide 6 by 6, and we can divide 36 by 6. And the greatest common factor of x and x squared is x. Now, 6x minus 36x squared, that's not equal to 6x. I can't just get rid of all that stuff. When I divide out the greatest common factor, what am I left with? After I divide the greatest common factor, 6x, out of each of those terms. What am I left with when I divide 6x out of the first term? 6x divided by 6x. 1. 36x squared divided by 6x. Negative 6x. You see how we got that with the top? I found the greatest common factor, and then I divided it out of each term. I undid the distributive property here. Now, the reason why that'll help us is now, oh look, what did I find here? I got this thing being multiplied by 6x up here, and then I'm dividing it by 6x. That's really convenient because I can
Undo.
Yeah, they'll undo each other. They cancel out. And I'm left with just what? 1 minus 6x.
That's the answer.
That's the answer.
Wait, oh my goodness! How did you do that?
I just showed you how. Okay, yes, question?
I just did I didn't do all that, but once I saw 6x, I guess that's the way the book works, that it was gonna have you crossing out another 6x. So
Yeah.
It's gonna be 6x.
Yeah, usually with these problems, whatever you have on the bottom, it might not be exactly the same as your greatest common factor, but it's often pretty similar to it. Yeah.
What's the test problem set on?
Up to 36. Up to and including 36.
Can we go over 36?
Yeah, we're going to do some review, but this is from 35, so this will be on the test tomorrow, this kind of thing. We can do some review, but first I want to make sure that I've answered any question about 39 and 40 problem sets that you have. Then I want to do 41 quickly.
Alright,
Yeah.
so, yeah.
What is that? You can run it?
Why do we learn
Yeah.
this type of math if we don't gotta use it in the future?
We do.
Bro, never
If you
seen
wanna
that
do-
to math.
If you want to do any kind of higher math, you need a solid
No,
founding.
what if you
algebra.
don't want to go into something like that?
Then go start working somewhere.
I gotta
Don't be here.
I
I
gotta.
gotta be at McDonald's right now.
You don't want to. You don't want
No,
to
I
learn.
like
if you
math.
don't want to learn, don't be here.
No, I do like.
Yeah, I
that's-
like math
when
too.
it, when
I
it comes
like
down to
math.
it, that's the answer. Is if you're not interested in learning, why would you spend your time doing this?
Exactly. I love learning. Learning is fun.
My GPA almost got from a 3.5 to a 2.1.
All right. Any other questions from 39 or 40 that you want to go over?
Number 39, I wanna go over number 4.
39, 4.
Yeah.
Okay. Yes. Here we just have to set it up properly. So this is 39, number 4.
Let me see if I did this.
They say if the product of 5 and a number is increased by 9, and this sum multiplied by 3, the result is 11 greater than the opposite of the number. Find the number. So we're going to have to set up an algebraic equation and then solve it. So let's set it up.
Wait, what's the answer?
If the product of 5 and a number is increased by 9, and this sum multiplied by 3, the result is 11 greater than the opposite of the number. Where do you want to start here? There are a couple different places we could start.
The very beginning.
Okay.
Times 3. Oh, wait. 3. I don't know. This is what I put. I put 3 parentheses 5 plus 9 equals 11. Then distributed. Got 15 and
So the first part, that's correct.
it is.
So 3 times 5n plus 9, that's correct
Oh yeah.
for the first part. The product of 5 and a number, they say that if the product of 5 and a number is increased by 9, and this sum is multiplied by 3, notice it's the sum that gets multiplied by 3. So first we add, then we multiply by 3. So that's correct for the first side. Then they tell us the result is, so equals what? 11 greater than the opposite of the number. What's 11 greater than the opposite of a number? Say it again. 11 greater than the opposite of the number. What does it mean 11 greater than something? Plus 11, right? It's 11 more than something. And it's 11 greater than what?
X.
A number.
Opposite of
Then the opposite of the number. What's the opposite of the number?
Negative.
Negative n. Yes, the opposite is negative n. So we've got, this is our equation that we should have set up. 3 open parentheses, 5n plus 9, close parentheses, equals negative n plus 11. At this point, solving is pretty straightforward. What do we have to do first here?
Distribute.
Distribute. So we get, 15n plus
27.
equals
And negative.
negative n plus 11. Now what do I do?
Take all your variables and put them to one side.
Yep, so I do that by doing what?
Plus n on that side. I mean both sides, yeah.
Yep,
Minus 27 on both.
and I subtract 27 on both sides. All right, now I'm left with what?
Uh,
Some stuff.
16n equals negative 16. I think
Yes. So n equals
1. Negative 1.
negative 1. Yep.
Yay!
All right, there you go. N equals negative 1. Any others from 39 or 40 you want to go over? Time for one more, maybe?
Yeah.
Oh, bear on it.
Number 2.
From which one?
39.
Okay, 39, number 2. Now, this is not going to be on the test, but it will be on the next test. 39, number 2.
7 to 10.
If the ratio of white marbles to black marbles is 7 to 10, there are 136 marbles in the bag. How many marbles are white? So, the ratio of white marbles to black marbles is 7 to 10. What would that look like if we wrote that out?
I think.
Okay, so, yeah, something is 7 to 10. What's 7 to 10?
White marble.
Marble,
Black.
or white, white marble, black marble.
Yeah, white marbles to black marbles is 7 to 10. So how am I going to write white marbles to black marbles?
W over B.
Yeah, W over B equals 7 over 10, right? White marbles to black marbles is 7 to 10.
Wait,
W over 100.
For all my homework, I put 7 over 10 equals W over B.
That's fine. Now, but be careful. So let's look at the information that they give us. They also tell us, what's the other piece of information that they give us?
That's 100. There's
There
136 black marbles.
No.
are 136 marbles in the bag.
There are 136 marbles in the bag.
Yeah.
So that's not black.
That's not black marbles, that's not white marbles, that's what?
136.
What?
Total.
Is the total. So what I don't actually want the ratio of white to black. I want the ratio of, now what, they give me the total, and what am I looking for? Am I looking
White
for the number?
marbles.
White. So I don't want white to black, I actually want white to total. What's my ratio of white to total? If white to black is 7 to 10, what's my ratio of white to total?
W over 136. Or white marbles
7
to
over
136.
I dropped
The ratio of white to black is 7 to 10, so what's the ratio of white to total? White is still 7 here. What would total be in that ratio?
136.
No.
10.
No.
17.
Yes.
17.
Now, where do we get the 17 from?
Because you add the numerator and denominator.
Right. So, in this ratio they gave us, what this means, this ratio says, is that for every seven white marbles, there are how many black marbles? For every 7 white marbles, there are 10 black marbles. But we don't want to know the relationship between white and black. We want to know the relationship between white and total. So we can keep white as 7. If we keep white as 7, the total is not just the white marbles, it's also the black marbles. So there are 7 white marbles for how many? Every how many in the total?
7.
Every 17. Obviously there are 7 white marbles for every 7 white marbles. Duh. And there are also 7 white marbles for every 10 black marbles. The total is white plus black. So the ratio of white to total is 7 to 17. Yes?
Yes, sir.
Okay, now what's the next piece of information that they give us? Or what's the...
T is 136.
Right, the total number of marbles is 136.
Yeah.
I did that wrong.
What
I got it wrong.
the thing that trips guys up about these ratio problems is keeping straight which numbers are your ratio numbers and which numbers are your actual numbers. And the ratio just tells you the general proportion. 7 to 10, white to black, that proportion would be the same whether you were dealing with 17 or 17 million marbles. You could have that proportion. Yes? Okay.
Is there?
It's just a ratio. So what I recommend that you do is you keep the ratio numbers on one side and you keep the actual numbers on the other side.
Yeah.
Those white to black, Those are your representing your actual numbers. Ratio 7 to 10. So here, and then what do we do to solve this? Quickly to solve it.
136 times 7, 17 times W.
17W equals 952. I think. Wait.
Oh
Yeah, 952.
Oh my goodness, he got it right.
And then what do we do?
Divide by 17.
Yeah, this is an annoying problem. But 952 divided by 17.
What?
What?
Nothing, no.
Oh, 952 divided by 17. This is annoying because what kind of number is 17?
Odd number.
Fine.
It's a prime number. In addition to being odd, it's prime.
Wait.
So the only way we can simplify this fraction is by dividing by 17.
56.
Yeah, that sounds right. Yeah, because 5 times 17 is 85. So it leaves over 10. 17 goes into 102. Yeah, 6 times. Yep.
Okay, 5 times 7 times.
Okay, white is
Weird.
now.
Amazing.
This might be obvious. This might be obvious, but it often isn't. If you get to a problem like this, they're talking about white and black marbles in a bag. If your answer involves a fraction or a decimal or a negative number, you probably did something wrong. There are probably not 39 and a half white marbles in the bag. Probably not.
Like,
Will this be on the test tomorrow?
This type of problem, no.
so we got the next test though.
Well, like, what if it was
I don't
one
know,
of those like
like,
marble bags where they just dumped everything out and they're like half
Like,
sliced?
All right, open your textbooks to page
I'm just thinking. My mom's
165. Lesson 41 quickly, then I'll open it up for review. Lesson 41 problem set will be due on Monday. That's fine.
Wait, we have homework?
Yeah, well, it's due Monday,
Oh.
not tomorrow.
Oh, whoa.
But this way you can get an early start on it. So problem set 41. What are like terms?
Like terms are terms that can go into both numbers.
Hey, they've been studying, you know the why?
No, I mean, yo.
What are like terms?
Numbers that can go into both numbers.
Terms that got the same variables.
They got it right. Things that we can add together are like terms. So if we've got 50 apples and 25 apples, those are like terms, right? You have 75 apples.
Yes.
But if you have 50 apples and 25 oranges, are those like terms?
No.
No, you can call them pieces of fruit, but then you have to talk about 50 pieces of fruit plus 25 pieces of fruit. Then you have 75 pieces of fruit. But it doesn't give you 75 apples or 75 oranges if you've got 50 apples and 25 oranges.
We don't like fruit.
You like fruit, man?
Yeah, like fruit.
This is being strange.
What is that?
Oh, you from the 63rd?
All right. The way that we tell if things are like terms is if they have the same variables. But what else do we have to have about the variables?
They also have to have the same exponent.
Some like terms or some possibly like terms here.
Can I get a
You like it.
third?
Okay.
From the voice.
Are these like terms?
Let me see. No.
Wait, stop.
Maybe.
No, they're not.
Yes, because you could bring up.
Yes, because you could bring up x and it'll be
Yes, you
negative
bring
2.
up x is negative.
Wait, what is that? The y? Is that
Bring up y
a
plus
4?
Okay, so it's not immediately obvious whether these are like terms or not.
Oh, that's a 2. Like,
Now notice
y squared.
Notice it's not immediately obvious because we've got these arranged in all sorts of different ways. Here we've got y on the bottom, here we've got on the top, here we've got on the top, but this one is b on the top, that one is b on the bottom. They're arranged differently, so it's not clear whether they're like terms or not.
Wait, it is because like.
Yeah, give me a second.
Wait, how was the last one like?
We'll get there, we'll get there, we'll get there, we'll get there.
Even how's the last one?
So,
Shut your mouth.
On the first one, if you bring that up, it'll be
So,
negative 3.
Now, you have to do this systematically. So remember we talked yesterday about how we can rearrange things with exponents. Usually, to make our lives easier, we're either going to bring all our variables to the top of the fraction, or we're going to make all our exponents positive, yes?
Yes.
So which one do you want to do here? To be systematic, you should pick a particular way to do it. You want to bring everything to the top, or do you want to make all the exponents positive? It doesn't matter which one you get. Okay, let's bring them up to the top. So this first one, we could bring them all to the bottom also, or make all the exponents negative, but that's annoying and dumb.
Yeah.
Unlike you guys.
Oh.
Okay, so let's bring everything to the top. But the first term, what happens when we bring everything to the top?
The exponent becomes
X
x3
to
x to the
the
negative 3, y squared becomes y squared instead of negative squared.
What you say?
So it'll be bx negative 2, and then y squared.
Right. So notice we bring the x cubed up top becomes x to the negative 3. X and x to the negative 3 combined to give us x to the negative 2 because this is x to the first, right? So they're multiplied, so we add the exponents 1 plus negative 3 gives us negative 2. And then y to the negative 2, when we bring it up, becomes y squared. Another thing I recommend is that when you're rearranging things, put all your variables in alphabetical order, or in the same order at least, because that'll also make your life easier. Okay, what about the next term? How can we simplify the next term? Oh, look, everything's already at the top. 3b y squared x to the negative 2. Nice. Now the third term,
4
4 is already on top.
y squared.
Okay, let's keep everything in the same order. So we have, actually, let's reorder this guy. So this one, let's do x to the negative 2 y squared. Just to make all the variables in the same order, to make it even more obvious. So 4, then what?
B x negative squared.
What? Okay, what happens with b? 4
It goes up.
and becomes
Negative.
B to x.
Negative 1.
b to the,
B negative to the negative first.
right, because right now it's b to the first on the bottom. So we bring it up top and flip it. B to the negative 1, and then what happens with the x? X,
It goes up and becomes
X negative squared.
x to the negative 2, and y squared is already on the top. Okay, now notice we brought all our variables to the top. We put them all in the same order. Now it's going to be blindingly obvious which ones are like terms and not. Is this one, are these two like terms?
Yes.
They both have b to the first, x to the negative 2, y squared. Great. Is this one also like term?
No.
No. Why?
Because B is what?
Right, b is raised to a different power. It's b raised to the negative
said-
first
no,
instead of the
I
first.
said-
All right.
Ah! He literally said, I was-
Loud noises!
Bro, you're recording, bro.
You got that?
He
You got
said, I was not gonna like her. I said, how are they like her?
Okay. All right. So that's the deal with these. And pretty straightforward, I think. Yes.
Yes.
Generally speaking, anytime you have a problem where you've got variables that are in different places in different terms, just pick something, some way to put them all together. Notice how this also enabled us to simplify this first fraction, where we had x on the top and x on the bottom, where now instead of having x in two places, we just have it in one place. Yes?
Yes.
Okay, so that's it with those. I recommend anytime that you're simplifying things that you do the following two things. First, either bring everything to the I recommend that you put your variables in alphabetical order. It doesn't matter what order you put them in mathematically, but alphabetical order is a nice, easy order to remember. And if they're all in the same order, it's easier for you to keep track of things. Yes?
Yes.
Okay, notice we could have also made all our exponents positive. It would have looked like this.
Crispy buttermilk.
You notice me, yeah. I know.
Notice we could have made all our exponents positive, and this also would have made it clear. These two have, on the top, both have by squared, and they have x squared on the bottom. This one doesn't have by squared on the top, and it doesn't have just x squared on the bottom. So you could do it that way also. Either one works. Okay, second thing, define the value of something, and then we need to plug it into something else. What do I mean? So let's look at the second. Let's look at the second example there, example 41.5. What they tell us, look, if x minus 5 equals 7, what is the value of x plus 4? Now remember, sit down. Remember that in any problem, in any particular problem, the same variable always has the same value. In a different problem, it might have a different value. But in the same problem, it always has the same value. So in this problem, anytime we talk about x, all those x's need to be equal to each other. That's the way that variables work. So when they tell us x, would you please stop talking and pay attention?
How did we get in that chair without getting stuff?
Dang, Braxton.
Notice how. Would you pay attention, please? So the x in the first part, x minus 5 equals 7, and the x in the second part, x plus 4, have to be the same. So now the first part, this is pretty easy. You don't even need to do it on the board. If x minus 5 equals 7, what's x?
12.
Right, so what's x plus 4? 16. That's how you do it. You use the first one is actually an equation. X minus 5 equals 7. That's an equation. We can solve that. And x is equal to 12. Then the second one, that's not an equation. We can only find the value of x plus 4 if we already have a value for x. Luckily, we just found a value for x in the first part. Yes?
Yes.
Makes some sense? Okay. I'll open it up now for review. We've got 10 minutes left. 41 will be due on Monday. Numbers, all of them except 4.
I can enjoy like
For days that we have tests or something, can you give us, like, you know how there's like test 9A, test 9B or something like
Yeah?
that? Can you give us the other form so we can study it for homework and we can do those?
No, the problem sets are like practice tests.
I've never seen before out of English.
Yo, just don't.
No, you can prank me Monday.
No.
Oh.
No, I'd rather pray Mr. Ponce.
Exactly.
So, problem set 41, all except for number 4, due Monday. So let's quickly run through 33 to 36, which are the 4 most recent that are on this test. So page 134, lesson 33. We talked about prime factors. Remember, a factor is something that you can divide out of a number, or something that, one of the things you multiply together to get to a number. And prime numbers, what's a prime number again?
Number that cannot be divided.
Except by
One.
and
Themselves.
itself, right? So 7 is prime, 17 is prime, 19 is prime, 23 is prime, 11 is prime, 13 is prime,
One.
1 it doesn't count as prime.
One is combined.
It would though if they counted.
Yeah, 0 and 1 just sort of do their own thing. Yeah, and as you said, all numbers except for prime numbers are called what?
Yeah, he's losing patience. Yo, if this happens to
They're called composite numbers. So any number that's a composite number, you can break it down into its prime factors. So, and just start dividing it by numbers and keep dividing those numbers until you get to primes. I recommend circling them once you get to the bottom, and then you can write it. Wow.
Yo,
Product of those.
Bro, it was.
Oh,
I did. You.
All right.
How can I have a stinking? I didn't even eat breakfast.
Page 138, lesson 34, greatest common factor. We've been talking about 35. We talked about dividing out the greatest common factor and canceling, like that problem that we went over from the problem set, where you've got these fractions. And then 36, on page 146, we talked about using the distributed property when we have fractions. Do you guys have any questions about any of that? You want to go over any of that?
no, sir, Captain.
Okay.
Wait, what?
We actually
Is
say
it-
on make
Father chucked my belt back here.
Look, guys, I want to.
Hey, wait, it's up until 36?
Yep.